All right, now back on to number 2. I literally just had to check to make sure I did that in my head correctly. I was like, I can't post that if that's wrong. All right, so number 2, using correct units, interpret the meaning of the integral from 0 to 2.4 of v of t dt in the context of this problem. So when we do the integral, so that's the antiderivative, so that's going to mean the distance traveled, oh, there goes Riley, in miles. Don't forget from what time to what time. All right, distance traveled in miles from 0 to 2.4 hours. All right, I could add a little bit more. It's the distance traveled in miles, or the distance Miss Danner traveled on the bike in miles. But just for all intents and purposes, to make it kind of condensed, it's the distance traveled in miles from 0 to 2.4 hours. So it's the total distance traveled. All right, so number 3 says approximate from 0 to 2.4 v of t dt using a midpoint Riemann sum with 3 subintervals. All right, so we're going to do 3. So if we go to our table, we go 1, 2, 3. Okay, so the first one goes from 0 to 0.8, so that's 0.8. And then we take the mid one, so we're going to use the one in the middle, 11.8, plus. And then from 0.8 to 1.6 is 0.8 times the one in the middle, 17.2, plus distance from 1.6 to 2.4 is 0.8 times the one in the middle, 16.8. All right, and if we're doing this times this, it's going to be miles. Okay?